Hi, thank you for watching this demonstration video on how to perform the vertical takeoff and transition to wing-borne flight in the AV-8B Harrier. So in this video I'll be going through how to do the pre-takeoff data assignment, the one-finger checks, the vertical takeoff, and the transition to wing-borne flight, culminating with a straight level flight. So the first thing we need to do is the pre-takeoff data assignment. So this is important so that the VREST computer displays correct information and doesn't tell you that you have more performance margin than you actually have. So the first thing I'm going to do is I'm going to request a rearm so that my operating weight is accurate. So in this case I'm going to take two M9s. This isn't something that you need to do when you're practicing, it's just something I'm doing to demonstrate how you would enter these values.
Copy.
So down here you can see I've got a snippet of a standard flight card. You can see over here this is what a full flight card looks like. Over the top there you've got the restrictions. All the way down the bottom, actually going on the next page, is the sea waiver checks. On this one we've got just the restrictions and the sea waiver field data section. So the first thing we'll do is we'll go ahead and we'll open up the VREST computer on the left MPCD. You can see it's already open on the right, but we're going to open it on the left. And straight away we've got these two options, BAW and BDI. You should already be familiar that BAW is the basic aircraft weight, and this is the figure that the aircraft uses at all times to calculate its VREST figures. So we need to give it an accurate operating weight so that I can actually tell how much it should be weighing minus the weight of its fuel and stalls that it recognizes as being present. So in this instance, our operating weight is 16,475 pounds. So we're just going to enter that on the UFCF here. 16,475. So to reiterate, come into the VREST menu. Straight away you'll get BAW and BDI. Colonize BAW. Type in your number on the scratch pad. Hit enter. All you need to do. For BDI, this is basic drag index. It's much the same. So down here it's telling me that my BDI will be 16. So we just type that in and we press enter. The BDI is relevant because when you look at your cruise page and it tells you how much fuel endurance you have and such like, this is how the aircraft knows how draggy it is in addition to its standard drag coefficient. So whilst it's not necessarily relevant to VSTOL operations, it's a good habit to build. Okay, next we need to put in the field data, so for that we actually need to go in the store menu. Outside air temperature is the first one we do. We want to make sure that's set to 29. It'll sometimes be a degree or so off. Field elevation in this case needs to be 94 feet. We don't need to worry about the engine, we do need to worry about FTAT, so runway distance in this case don't worry about. Runway heading in this case is 338 degrees because we're just pointing ourselves into the wind, and the ground wind's 338 at 009. And you can see all of that information here. Okay, so that's the pre-takeoff data assignment. Next we're going to go through the one-finger checks. So the one-finger checks for the conventional takeoff. First of all, before we do that, I do apologise, before we do that we need to check what our fuel water weight is. So coming over to VTO here, you can see that with with water on, we can take off with 3,292 pounds of fuel and water, so we need a minus 500 pounds from that figure. With dry, it's 1,816. So 3,293 minus 500 would be 2,793. So we're a little bit high, so we need to just take some fuel out there. So we'll bring it down to about 30% or so.
Request refueling. Request rearming. Copy.
Okay, so we've now completed the pre-takeoff data assignment, and we've also completed the fuel reduction to bring ourselves under the maximum fuel plus water weight limit minus the water to get the fuel limit only for the maneuver. So the next thing we're going to do is the one finger checks for the vertical takeoff, which are quite simple. So we're going to keep the stow stop in the clear. We're going to bring the nozzles back to 84. I'm going to look over the nose to verify that. So nozzles back to 82. Okay, and then flaps are going to come down to V-stall. Nose wheel steering is going to be left in the off position. Combat water is going to be turned on in this case because it's more than 20 degrees outside and we're trying to do vertical takeoff. I'm going to put the water into the on position. And then finally, using the engine page, we're going to trim 2 degrees nose down, which looks like it's already trimmed by default. Okay, so now I'm going to open up the hood on the right MPCD, and you would normally open up the EHSD on the left MPCD if you were going to be entering into the visual circuit, which we're not doing today, but it's good practice to do it anyway. Okay, so parking brakes off. I'm going to quickly verbally walk through the procedure and then I'm going to perform it. So the vertical takeoff is a little bit easier than the press up because you're not trying to keep station fore, aft, left and right. It's a little bit trickier than the press up because you then have to perform the wing transition from jet-borne to wing-borne flight. So for the vertical takeoff, we're going to hold the brakes. We're going to gently but fairly progressively add the power up to max power to allow the aircraft to take off. Once we're either passing through 50 feet AGL or we're clear of obstacles, we're then going to simultaneously raise the nose and gently bring the nozzles forward using the capture attitude technique. This is the start of the transition to wing-borne flight. So I'll lead very slightly with the nozzles, meaning I'll bring the nozzles forward slightly before I bring the nose up, but only by a split second. The witch's hat is going to go straight onto the pitch carrots, which you can see clipping just at the very top of the hood there. And essentially, I'm going to walk the nozzles forward, and my limiting factor will be whether or not the velocity vector is above the horizon. If the velocity vector drops below the horizon, I've raised the nozzles too fast, and I just need to bring them back a little bit to maintain a positive rate of climb. Once the nozzles get to 25 degrees, I'll pause. I'll slightly pull back on the power to stop the engine from burning out. I'll bring my flaps to the auto position first, and then I'll bring my gear up. That's in case I have an engine failure, so that I already have my gear down to somewhat cushion the landing if there is a land ahead available, and there isn't the time to eject. So at 25 degrees nozzles, it will be flaps, then gear. I'll then continue to program the nozzles all the way forward to 0. I'll then clear the stow stop, turn the water off, and then put the flaps into cruise. So I'll perform that now. So holding the brakes, adding full power. Aircraft lifts off the ground, looking at the radar altimeter there. There's 50 feet, capture attitude technique, nozzles coming forward, stick coming up slightly on the horizon, forward to 25 degrees there, power back slightly, flaps up to the auto position, and if I can find it, gear up also. Now it's nozzles all the way forward, coming down, make sure the stow stop's clear, turn the water off, power back slightly, into the nav master mode. Look out above and behind once you hit 300 knots. Flap straight away into cruise, full power again, and we're going to climb for 300 knots. And let's level out at 10,000 feet. So bring the nose down to try and maintain 300 knots as best as we can. And there's 9,000 feet. bringing the nose forward for 10,000 and coming back on the power a little bit and trimming. And there you have it, the vertical takeoff transition to wing-borne flight. The key things to remember are the capture attitude technique, so leading slightly with the nozzles, bringing the nose up. You might find, and as you saw there, I actually just relaxed the forward pressure on the stick, and that was enough for the nose to come up to the pitch carrots. And then actually I push forward a little bit on the nose as I program the nozzles forward to stop the nose from rising too much. Witcher's hat on the pitch carrots, progressively bring the nozzles forward to 25 degrees. At that point, flaps to the auto position, then gear up. Remember to bring the power back slightly so you don't burn the engine out, then nozzles all the way forward, clear your stop, turn your water off, and then put the flaps in the cruise position and continue with the climb. I hope you found this video useful. If you have any questions, please feel free to contact me.